Right. Now we'll see the other parameters. But the other parameters are the fifth parameters. We can say A, B, C, D parameters. A, B, C, D parameters. And these are also called as transmission parameters. Transmission parameters. And these parameters we use for the analysis of a transmission line. That's why these are called as a transmission parameters, which we used to simply call it as a T parameters. We used to say, which we used to call it as what? T parameters. In case of T parameters, the equations here the independent variables, here the dependent variables will take it as V1 and I1. These are the dependent variables. That is, V1 is equal to A V2 minus B I2. Next, I1 is equal to C V2 minus D I2. Yes. Now we can write matrix form as what? V1 I1, which is equal to what I can say here? A B C D, and which is equal to V2 minus I2. This matrix. Okay, these are what it is a dependent, and these are the independent variables. Now we'll get these parameters now here, one by one here. A. Tell me how we'll get this A now here. A is equal to, we can see, A is equal to what? V1 by V2. V1 by V2 when I2 equal to 0. And what the units are? No units. No units. Next, C is equal to I1 by V2. C is equal to what? I1 by V2 when I2 equal to 0. And what the units are here? No. Next, B is equal to what? B is equal to minus V1 by I2 minus V1 by I2 when V2 equal to 0. When V2 equal to 0, the units are what now here? Ohms. And the D is equal to what? Minus I1 by I2 minus I1 by I2. No units now. What the when the V2 is equal to 0? There is no units. So these are the T parameter equation. A V2 minus B I2. I1 is C V2 minus D I2. Right. For this we can now develop the network. Right. There is no standard network for this thing here. Now the conditions we can see. If A is equal to D, then we can call this network as a symmetrical network. A is equal to D is called as a symmetrical condition. And if det now this matrix, you can say this is A, B, C, D. If the det is equal to 1, this is called as a reciprocal condition. This is a reciprocal condition. Isn't it? This is about what? transmission parameters, T parameters. Now we'll see the one more parameters we have, that is inverse transmission parameters. The sixth one is inverse transmission parameters. Inverse transmission parameters. And this we used to also call it as a small t parameters, we used to indicate small t parameters. And same as earlier here, what we used to do, simply we interchange the dependent to independent to dependent. So here previously this box will interchange this matrix and this matrix. Now here that is V2 and I2, and which is equal to, we can say it is A, B, C, D, and then V1 minus I1. That's all. Now we can see this equation. If we want, we can write the equations as this is V2 is equal to A V1 minus B I1, I2 equal to C V1 minus D I1, isn't it? Now we will see these parameters also. How we will get these parameters? Now here A, small a, which is equal to what I can say here, V2 by V1 when I1 equal to 0 now, and no units, and the B, which is equal to, B is equal to minus V2 by I1 when V1 equal to 0 now, and over the units are ohms. C is equal to I2 by V1 when I1 equal to 0, the units are mho, and the D is equal to minus I2 by I1 when V1 equal to 0, the units are no units, like this. These are inverse transmission parameters. But this inverse transmission parameters also, we don't have any standard network. We cannot develop the equivalent circuit now here. And the condition for symmetrical reciprocal, that is same as earlier. If A is equal to D, then we can call the network is a symmetrical. Then we can call the network is a symmetrical. This is a very important thing. Next, as usual, if determinant A, B, C, D, if that is equal to 1, and this is the condition for a reciprocal condition. Reciprocal. No. Now you can see here, previously we have seen these parameters. Let us call this parameters V1 I1, V2 I2. Now if I say this thing, let us call this parameter, this is a something P matrix, which is equal to something A matrix, ABCD. So let us say T matrix, I can say capital T, T matrix, into, let us call this as a Q matrix. Assume. So from this, now if I do the T inverse on both sides, so here what we got, it is a P matrix is equal to what, it is a T matrix into Q matrix. Now if I do the T inverse on both sides, then the T inverse into P matrix, which is equal to what now here, Q matrix will get now. So from this Q matrix, which is equal to what now here, T inverse into P matrix now here. You see carefully, P matrix is V1, the P matrix, this is V1 I1, and the Q matrix are what, V2 minus I2. This thing we need to satisfy here. Look at now, just now we have seen here, this is what we can say this as a, here this matrix here is this thing. We will write this equation here. Now if you see carefully, previously the small ABCD parameter equal, so this is what we got, it is a V2 I2, which is equal to what now here, A, B, C, D, and which is equal to what now, V1 minus I1 now. Now if you see this thing, this matrix here, Q means what, V2 minus I2, and that equal to what now here, yes, T inverse into P. P matrix is what, V1 I1. Now I can compare this one with this thing. Is both are same or not? You can see, is both are same or not? You can see this thing here. This thing and this thing both are same or not? No. Here we have minus I2, but here we have plus I2. Plus I1, here we have minus I1 now. So from this what we can say here, if I indicate this as a small t parameters like this and this capital T parameters, so from this what we can conclude now here, the first, previously we have seen here, this is Y matrix, which is equal to what, Z inverse. Next, G matrix, which is equal to what, H inverse. And third one, now small t matrix, can I call it as inverse of the capital T matrix? No. These are not, this property not satisfied in case of a small t and the capital T. Why? Because of this here, the negative sign, here there is no negative sign. Here we have negative, here negative sign, there is no negative sign here. Because of this negative sign, this property not satisfied. Remember here. So T is not equal to, small t is not equal to T inverse. Very important point. Very important point. Try to remember. Right. This thing. This is about all the 6 parameters. All the 6 parameters. Here we can see this thing here. The thing we should remember, this is symmetry condition and the reciprocal condition. Symmetry condition and the reciprocal condition, you need to remember carefully. Very important. Don't get confused. So for the Z parameters and Y is same, Z and Y is same, G and H is same, and T and small t also same. So for the Z parameters, what the condition is? A symmetric condition is Z11 equal to Z22. Reciprocal is Z12 equal to Z21. Next, H parameters is what? That is equal to 1. H11, H12, H21, H22, that is equal to 1. Here H12 is equal to minus H21. Reciprocal condition. Next, ABCD parameters. Yes, T matrix now here. So the T matrix condition is what? Symmetrical. The symmetrical condition is A must be equal to D. Symmetrical. And here det is equal to 1. What det is in A, B, C, D. And here the det is equal to 1 here. Yes. You see this thing here. When the det is equal to 1, in case H matrix is a symmetry, but ABCD matrix is a reciprocal. Don't get confused between these two. Don't get confused between these two here. Right? This will be, and these are the condition for symmetrical and